Welcome to Chapter 4. When most people hear Lean, they automatically think of tools such as 5S and Kanban. Companies think they can simply implement a couple of these tools and reap the benefits of Lean. But for Lean to work, a company must use the tools to support the greater Lean principles and methods, and no two methods are more vital to the success of Lean than just-in-time production and JIT. At the end of this chapter, you and Tom will be able to define just-in-time, JIT, in Lean production, identify the supporting Lean tools of the JIT pillar of LPS, picture the layout of a Lean shop floor that's focused on flow between value-adding processes, understand the function of takt time in a Lean flow system, define the difference between push and pull production, understand the roles of tools such as supermarkets and pull signals in a pull system, explain the definition and purpose of Heijun-ka, identify the relationship between monthly, weekly, and daily leveled schedules, and list the 4 types of useful finished goods inventory in a leveled schedule. Ready to test your skills? Click the test button to take the test at any time. In the Lean way, the right process will produce the right results, and the right process is constructed through the use of several Lean concepts or methods and the Lean way principles that they come from. Lean methods are those components that companies implement to go Lean, tools that bring about change in a company by lowering cost and increasing quality and efficiency. The methods of Lean complete the house of the Lean way and Lean production system. They support the pillars of just-in-time and JIT, which allow LPS to eliminate waste and poor quality. These concepts must work together as a system and spread throughout the company, forming an imprint on how leaders lead, managers supervise, and employees work together. However, even though they get all the press and glamour, the methods should only serve a supporting role.
Finally, time for the real Lean business. Let the suits worry about leadership and training. I'm ready to get to work.
Whoa, Tom, I don't think you were listening. Lean concepts are very important, of course, but they're not the Lean cure-all. In fact, rather than fixing much, these tools mostly show how badly your operations are broken. A change in culture must come first in your company, with an attitude of respect for all people. Many companies mistakenly believe the methods to be the actual LPS. They are only the tactical means by which a company becomes Lean. They are at their best when they have the backing of a Lean culture and long-term leadership philosophy. After collectively recognizing the need to change, working together on improvements, and committing to years of long-term management direction, a company can develop the Lean methods to the point that they actually work as a system. Think of it this way. A successful diet requires a lifestyle change. You have to make better eating decisions that focus on long-term results, like the Lean leadership principles. And you have to show respect for your body with your exercise decisions, like Lean people principles. Unfortunately, the conflicts that often result from implementing Lean concepts, along with the pain of change, cause many companies to abandon a serious Lean effort within the first year. Much like diet and exercise, the Lean methods must be permanent components of a process in order to maintain and enhance performance. And like diet and exercise for eliminating weight, LPS has 2 very important pillars, with several supporting methods for eliminating waste: just-in-time, JIT, and JIT. The principles of JIT. On the Lean Way tree, 2 main branches grow from the Lean culture of leadership and empowered people, representing the 2 main pillars of the Lean production system, JIT and JIT. The foliage that springs from each main branch represents the principles and tools that allow an organization to implement a complete Lean production system. For now, let's focus on the set of Lean principles that facilitate just-in-time production, made up of 3 main tools: flow, pull, and schedule leveling. A good place to start a Lean implementation is to redesign your processes and floor layout to create a continuous flow system. In this production system, you produce or move small amounts of items through processing steps as continuously as possible, with each operation making only what's requested by the next. A best practice to convert to continuous flow is to value stream map one key product family. A team will diagram the flow of information originating from the customer and map the flow of material beginning at receipt from suppliers all the way through the production system. The team identifies the waste in the current map state and then works to design an improved future map state. A Lean company makes flow evident throughout its organizational culture. Flow is the focus of its continuous improvement events and considered in the development of its people.
At Handle Vision, we have product flowing like a river all over the place.
Actually, with your layout, the flow is more like a plate of tangled spaghetti, creating a dam of work in progress, WIP, that hides all the waste.
But that dam is necessary. It isn't really practical to change the layout. Our equipment runs in batches at different cycle times and for different customer orders. It's complicated.
I understand it can seem overwhelming, but part of the beauty of creating flow is that it simplifies and unites your operations. In a continuous flow system, waste has no place to hide. Linking people and processes lowers the water level to expose your problems. You may uncover excess inventory, WIP, and defects. For this reason, flow forces the implementation of other lean concepts to eliminate the waste.
So, how do you start draining this dam?
To create flow, you single out the operations that add value and then attempt a layout that moves closer to one-piece product flow. A forefather of Lean famously stated that you need to look at the time from the moment the customer gives you an order to the point where you collect the cash, and reduce that time by shrinking or removing non-value-added activity.
So who determines what has value?
Value-adding work is an operation that adds value to the product as perceived by the customer. You erase unnecessary non-value-adding work and reduce work that's necessary only given the current setup of your processes. Creating a flow setup. Every operation is different. There is no canned lean recipe to reduce waste through a specific layout. To deal with the realities of specific operations, value stream mapping, deep thinking, and problem solving are critical. To grasp a deeper understanding, you need to answer a lot of why questions. For instance, in the traditional setup shown here, is there a logical reason for taking material on this long journey throughout the entire floor? As companies explore, they generally find that many flow problems are caused by people being unaware of what to build or move, how much to build or move, and when to build or move it. A proper lean layout makes this information accurate and obvious. A cellular setup. A common lean setup, on the other hand, is to create multiple cells for different product families. A cell, or line, is a setup of product operations immediately adjacent to each other in the order of processing, so that single-piece processing can take place in a continuous flow. A cellular setup shrinks the big or vague picture down to a simple or obvious picture that everyone can see and understand. The questions of what, how much, and when become much easier for teams to answer and control. A big advantage of this setup is that operators can handle multiple processes, and the number of operators can change when customer demand changes.
So you have all these cells. How do you coordinate them? I could see one team producing quickly while another is saddled with slow machines.
Good point. In a flow system, time influences the physical layout of a cell as well as the resources assigned to the cell. Takt time represents customer demand in a flow system, the true heartbeat of the lean way. When you take the available production time and divide it by the units required by the customer, per day for instance, you get the takt time, or the interval of time that should elapse between each finished piece. In this way, each customer order, row, sends a chain reaction down the process to produce more product. Benefits of flow. A continuous flow system allows a lean company to better serve customers while reducing production costs. Although a true continuous flow system is virtually impossible, the LPS vision of this system leads to the elimination of the 7 major wastes of traditional batch and queue production. Quality. In a small batch flow system, ideally one-piece flow, each operator or piece of equipment is relied upon to inspect product before passing it on and to inspect product coming in so that defects aren't created or missed. Flexibility. Reducing the amount of time required to create a product allows flexibility in filling new customer orders. Customers get exactly what they want in the amount they want when they want it. A cellular setup also allows for quick repurposing of a process line. Flexibility gives you an earlier return on investment and prevents the customer from paying extra for small product runs. Productivity. When you eliminate non-value-adding work, you can identify both busy and idle people and repurpose resources to focus only on productive tasks. You also take out unnecessary transport, rework, safety delays, and so on. Morale. In this system, people only do value-adding work with obvious results, leading to higher job satisfaction. They also face fewer safety risks due to the reduced need for forklifts and manual box movement, meaning less inventory. Space. A continuous flow system frees equipment, floor space, materials, energy, and employee time for more productive use. Gone are the piles of inventory and yards of space between departments. Cost. On one hand, a flow system frees up the money formerly invested in space, inventory, and unused equipment. On the other, it makes a company's profit model more customer-focused. Instead of cost plus profit equals price, it's price minus cost equals profit. Costs are not passed on to the customer. Challenges of flow. There's no doubt that creating flow will speed up production, reduce costs, and pace the flow of product to the demand of the customer. However, it can be a slow and steady climb to see results. Implementing flow requires patience and the ability to see past short-term problems. Resistance. A flow system changes the way people do their jobs and often requires them to learn new jobs. At first, workers may resist this trip outside of their comfort zone. They may see lean as an increase in work or hours, when actually flow decreases wasteful work and hours. No safety net. When you link operations and machines and minimize inventory, the entire line goes down if a single machine goes down. Also, operators must be empowered to stop production if an abnormality arises. In this system, the group relies on every individual. Without the safety net of inventory, people on the line must think, improve, and maintain high quality. Short-term, unexpected costs. The closer you get to continuous flow, the more problems you'll surface, problems that must be fixed right away. The side effect of this is that you'll face problems you didn't know existed or couldn't fix, and often production will have to stop. Many companies give in to the pressure of short-term losses instead of focusing on the long-term gains. Unfit areas. Not all areas of the floor may be fit for a continuous flow setup. Here are some of the most common challenges. Equipment generally is large and costly to move. Equipment is designed to process parts quickly so it can serve many product lines. The purchase of smaller, dedicated equipment is desirable, but often not cost justifiable.
So we push material through a cell to make product one piece at a time and then pass it on to the customer.
Not exactly. You're describing the traditional push system of production. As we discussed earlier, continuous flow is the ideal state. Because you can't accomplish perfect continuous flow, you compromise by creating a system that pulls material rather than pushes it. In a push system, product is based only on forecasts, creating many wastes. If you schedule and produce according to your best guess of demand, you'll be wrong much of the time, leaving you with excess inventory. And if you wait for a specific order and then try to push it through all operations, you'll cause delays and customers won't tolerate waiting. In a pull system, you minimize overproduction by making only what's taken from a process. In other words, you produce items only when customers show demand.
I can't see flow moving backward. Rivers flow one way.
Product is still flowing through value-adding processes without interruption. However, you can control the direction and speed of the flow with production signals.
Just seems so backward. Why give all the power to the customer?
It is backward. The customer should control production, initiating pull by consumption. Think of the things you replenish. You don't get gas unless you're running low, right?
So how does this pull affect a guy working in raw materials?
The customer simply can mean the next operation in the process. If a forming operation requires more raw material, for instance, you provide it. The customer pulls from the top down.
But what if disaster strikes? We have no inventory safety net.
Maintaining a supermarket inventory. That's correct. It's wasteful to pile inventory like a family bracing against a bad storm. But while the goal is zero inventory, a buffer is often necessary for events such as customer spikes in demand. Buffer also acts as a break point between processes to protect against differences in changeover and cycle times. In these breaks, part supermarkets hold the inventory that protects the process and allows for flexibility in filling customer orders. A supermarket is a location where a controlled amount of standard inventory, like ingredients on the shelves, is stored to supply production processes like grocery customers. It works as a compromise between push and zero inventory.
No way! Our plant is too big. How do we communicate between these supermarkets? Broadcast orders over the PA?
The lean way is to utilize pull signals to handle communication and ordering. There are many types of signals, both simple and complex. Signals may be empty containers, painted lines, signs, or even lights. A more advanced lean company may use Kanban. A Kanban is a signal card that manages the production and withdrawal between processes. An operator takes material from a bin and removes the container's Kanban, which signals that this material needs to be withdrawn from an upstream process to replace it. When material is taken from that process, a signal goes upstream to produce that material. Kanban and supermarkets are also effective for managing differing cycle times between processes or machines. Think of Kanban as the true nervous system of flow and pull production.
Pull signals? Sounds pretty technical. Are we shining lights from one station to another or installing some complex computer system to track orders?
Glad you asked. Many companies hear Lean or Kanban and automatically think a huge tech upgrade is in order. The Lean way is to keep it simple, especially when it comes to tools like pull signals. Pull signals are visual controls that can be interpreted in a single glance. A tag card, an empty product bin, an empty slot on the supermarket shelf, and so on. You fill up your gas when the gauge reads E. You buy eggs when the carton looks empty. And think of how a traditional fast food cook knows when to make more burgers. When the product level falls below a crudely drawn line, presto, time to hit the grill.
Okay, I'm seeing the light. We use signals to eliminate all the inventory and kill waste once and for all.
No, Tom, you must remember that a tool like Kanban is still considered inventory, and inventory is waste. Kanban and the pull system as a whole defeats the cause of most waste, anticipation, but it's only a compromise. A lean company will continually look to Kaizen and reflection to reduce the need for inventory.
But say your customer's ordering behavior is a bit crazy. Maybe we don't need warehouses of product, but some inventory still seems necessary to me here and there, especially if different departments have different schedule. But then Lean eliminates the silos in the organization, doesn't it?
Good catch. Independence and variation aren't looked upon too kindly in the Lean way. You raise a good point, though. Customer demand is always changing, but that doesn't require you to hold a ton of inventory. After all, you don't go to the grocery every other day for a needed item, right? That would be terribly inconvenient. Pull and signals don't work in a vacuum. A company with mixed model production needs should coordinate its entire flow system under a leveled production schedule to a degree practical for its situation. Hungry Frank's Build-A-Burger line instructions. It's time to show your mastery of just-in-time pull and flow. Your job is to drag and drop the available ingredients from the topping supermarket to create each burger ordered by a customer. After piling the toppings, finish the burger with a bun top. When a topping falls below the minimum level line, you must click the reorder button to replenish the supply. Remember, you lose a life at Hungry Frank's for not giving customers what they want, in the amount they want, when they want it. 3 mistakes and you're off the line. Close the instructions to begin. Uh-oh, a topping supply is running low. Reorder. Sorry, maybe the burger line isn't the best work for you here at Hungry Frank's. How are you with a spatula? Please continue to the next activity. The process of leveling out the production schedule is commonly known as Heijun-ka. Heijun-ka is a means of smoothing the volume and mix of items produced over a fixed period of time so that material flows more evenly. In terms of volume, the goal is to manipulate small amounts of supermarket inventory in order to repetitively produce nearly the same pattern of product, all to the tune of takt time. The mix is adjusted for specific customer orders. In terms of product type, the goal is to produce many different types of product or parts in smaller batches according to a repetitive sequence. Heijun-ka benefits your processes, employees, and customers if they are more stable than erratic. It forms a three-pronged attack with flow and pull in a JIT system. Problem solved by Heijun-ka. Leveling the production schedule is fundamental to eliminating all wastes, muda, but specifically Heijun-ka gets rid of overburdening, muri, of people, equipment, and unevenness, mura, in the production process. Both of these wastes have adverse effects on your lead time, inventory levels, and morale, the happiness of your employees, and especially your customers. Think of it as simply lowering the peaks and raising the valleys of what you produce or serve, like a waitress in a restaurant. What would happen if she was given 4 more tables than any other waitress? It would negatively affect employee morale, customer morale, and the staff production as a whole. Necessity number 1, the customer. A traditional production system features weekly schedules, if not longer, for each product, and each is produced in total, in sequence, during the week. But what happens if, after producing 10,000 of product A, you suddenly get an order of 5,000 of product C? A traditional company would face the bullwhip effect. It would inventory all the A, endure a long changeover process, and then overburden employees to hustle with product C. Heijun-ka handles shifts in demand more easily. Through the use of signals and supermarkets, you can spread changes in demand over multiple days. And you're always producing a product mixture based on daily and even hourly schedules, so the customer can count on flexibility. You also have to protect your processes. Producing in batches requires a start and stop mentality that leaves some people and machines taxed, maybe needing overtime to make all of product A in the first half of a month, while others wait for work, maybe those more dedicated to product C. This combination means you need to have on hand the equipment, materials, and people to run the highest level of production, even if requirements are lower, to build up inventory and reduce cost. This also works to prevent high quality.
Okay, but do you just wing it each day with production? Our bosses have a saying, plan for perfection.
That's great, but I might suggest changing it to plan every day for perfection. The lean way is to plan in the short term to achieve long-term results. The difference in the plans is that a lean plan considers the customer by incorporating balance and flexibility into its forecasts. A leveled production schedule is actually a combination of 3 different types of schedules that allows order information to quickly hit the production process. A lean schedule still relies on a monthly forecast. You estimate the amount of product to be made over a month's time based on demand, the time of year, industry information, past customer behavior, and so on. The difference lies in the adherence to the forecast. A lean monthly forecast isn't set in stone. It's a living plan that evolves at any sign of change. Whereas a traditional company will hit the targets exactly, barring any major problems, a lean company's actual production may differ from the monthly forecast. This is where the production plan becomes more detailed. 4 times a month, the schedule is updated to reflect specific orders made by customers. Whereas the monthly schedule may focus only on the total number of product to be produced in each line, the weekly schedule can start to break down how machines and people will be used to create a product balance throughout each week. You can see which products are in high demand and how the rest of the products will be made around them. This is the exact production volume for each day of work, taking into account final order changes made from the previous day or two. Customers can call in custom orders or built-to-order product made possible by just-in-time production philosophies. With the weekly and daily demand determined, you can calculate the takt time for each product based on the time you have available to produce. This will determine how much of each product must be made every shift, hour, minute, and so on. Employees in some cells or lines may produce based on tools such as Heijunka boxes, which break down production into small increments that pace the day's work.
But what about customer relationships? Ours would never go for this. The orders aren't always level. Sometimes they want 1,000 dog handles, and sometimes they want 50 food handles. And they never give us enough lead time to make them.
Good point. Heijunka takes a lot of trust and coordination. Success depends on managing a small amount of inventory, or waste, with your suppliers and customers in mind. This finished goods inventory, FGI, is made up of highly consumed product. It's necessary waste caused by sporadic customer or supplier orders when you perhaps don't have the lead time matching the demand. There are three main types of FGI that keep the entire extended business flowing just in time with a leveled schedule. A successful lean company can balance custom and built-to-order scheduling with forecasting to have the flexibility to meet all customer needs, both reliable and spontaneous. In order to level production with some particularly sporadic customers, you may have to hold small amounts of finished products at shipping, ready to be loaded immediately. This may be the case when first working with a customer undergoing a lean transition. With this strategy, you can execute a pull system effectively by building at level pace goods that you're confident will be sold and meeting demand changes with stores of inventory. Certain products are in demand only during certain seasons, like your candy cane handles. Rather than burden your processes during the high-volume times of year, you can slowly create seasonal inventory throughout the year to level production. Safety stock protects the customer in the event of an unexpected problem in your processes. If a machine experiences extended downtime, safety stock continues to supply the customer to maintain flow and good relations. It also protects the company from unexpected customer demand for product that isn't seasonal. Any number of events could call for the use of safety stock, anything from natural disasters to a celebrity suddenly using one of your cups. The amount of safety stock necessary lowers as you raise quality in your processes with JIT, Jidoka, and other lean methods, such as total productive maintenance. Benefits of Heijunka. Flexibility, the ability to place and change orders. Increased satisfaction, get what they want when they want it. Shorter lead time, no more waiting weeks after placing an order. Reduced prices, cost savings from the company and suppliers passed on. Shorter lead time. No need to wait for changeovers or suffer from demand changes. Reduced inventory. Supplying a varying amount of products continuously to meet demand. JIT flow. Supplying what's ordered when it's ordered based on a level set of orders. Protected schedule. Any shift in demand is covered by a flexible process and FGI. Reduced cost. Less inventory and other waste leads to cost savings. Shorter lead time. Shifts in demand won't require product to sit idle in inventory. Reduced inventory. No warehouses of products filled with unsold goods or changed orders. Reduced cost. Less overtime paid during high-volume periods, less inventory, and so on. JIT flow. Individual products made and supplied based on takt time. Process balance. Resources set up so that work is manageable, balanced, and continuous. Challenges of Heijunka. Requires trust. Faith in a product supplier to meet changes in demand with no safety net. Requires balance. The ability to order and accept small volumes of a variety of products on a continuous basis. Requires lean methods. Heijunka relies on JIT, quick changeovers, TPM, standard work, and so on. Requires trust. Changes can be made every week to expected production. Requires target accuracy. No batches requires a predictable lead time and ability to meet deadlines. Requires some waste. Certain levels of FGI protect the customer, company, and suppliers. Requires lean methods. Heijunka relies on JIT, quick changeovers, TPM, standard work, and so on. Requires company buy-in. Heijunka runs from the start of the value stream to the end user, relying on every department between. requires target accuracy. No batches requires a predictable lead time and ability to meet deadlines. Heijun Ka at Hungry Frank's Instructions. Time to show your mastery of Heijun Ka within JIT. Your job is to manage Hungry Frank's production schedule according to takt time. Click the green product button to choose the production run of one of 3 menu choices. 1. Biggie Burger, 2. Chicky Sandwich, or 3. Frank's Deluxe. Clicking this button will begin production of that item. Clicking another product's button will indicate the production of that item. During your 3-minute shift, representing 180 seconds, your line must make 45 menu items total. The most popular item on your menu is the Chicky Sandwich. Second is the Biggie Burger. And third is Frank's Deluxe. Your goal is to level the production schedule so that you don't overburden employees, create wasteful inventory, or leave your customers unsatisfied. Use the takt time meter as your guide. Pay attention to the time required to produce each product and to change over to the production of a different product. Try to keep your red takt time pace indicator in line with the desired takt time to maintain the proper pace. Good luck! Not bad. You are almost able to run a leveled production schedule. Try pacing your production based on popular customer demand and creating a leveled schedule that repeats a production pattern over and over during the 3-minute time. Congratulations, you have completed Chapter 4. You should now have a good understanding of the definition of just-in-time,